commercial air refrigeration air defrost. Medium temperature refrigerators will frost. If we want to achieve a 35-degree box, what temperature are we going to need our evaporator to be?
35.
At least 25 for a 10-degree temperature difference like our walk-in refrigerator. At least 25. Is that below freezing?
Yes.
We're going to develop ice. There's no doubt about it. If the space temperature is between 36 and 40 and the evaporator temperature is 15 to 25, then coil frosting is normal. The coil will defrost during its off cycle. That's pretty much what we're doing with our walk-in box right now. We're allowing it to off cycle defrost, but it's probably a good idea to walk back there and see if that coil's nice and clear still, because we might have to put the defrost timer on it and give ourselves a timed defrost. Medium temperature refrigerators use the thermostat off cycle to melt frost accumulation. Sometimes a time clock is needed to extend the length of the off cycle. The following slide is a common wiring arrangement for a walk-in refrigerator. And I'm hoping, yeah, it doesn't look all that different from our lab, does it? We've got a pump down solenoid. We've got the evaporator fan, and we've got a thermostat. The thermostat supplies power to the pump down solenoid, back to neutral. We've got line voltage thermostat, a line voltage solenoid, and that's going to release the refrigerant. They're not showing the rest of it yet. But when power is applied, we're going to have an open liquid line, and the evaporator is going to turn on. The common time clock is used for cycling outdoor lights, heaters, etc. The clock in the example has one set of normally closed contacts. It is cycling the refrigeration compressor for an extended off cycle. And there's the old school time clock. That's the way old school time clock. You probably see the old school time clocks as something that look like this. But those are fading away, and this is becoming the time clock that you see most often. There's normally closed switch right there, and here is your load. That's your neutral side. Inside here, there's a wire, wherever it is, right here where you connect L1, there's a wire that comes up here that runs this timer motor and back to the neutral connection there. The dial rotation sets the time of day, and these little guys right here trip the thing off or on. The time clock and refrigeration. If we did have frost on our coil in the walk-in box, what we would do is add a off cycle. We just wire in our timer that we already have on the board there. We might do it just for fun. We're going to wire in our timer on the board, and say right around 2 a.m. it's going to go through an off cycle. Really, considering how much stuff is in there, I only need it on for prospective students. That's the only reason I run it all the time. So I could program the thing to be off unless it's in between the hours of 7 o'clock to 10. And the rest of the time it'd be off. I could probably get away with going to 9. But I could do it with that time clock. This gives the evaporator extra time to air defrost. The clock shuts off the compressor while the evaporator fan continues to run. So the compressor's off, the evaporator fan's going to continue to run, and that's going to warm up that coil eventually to the 35 degrees that box temperature is, and you should melt that ice pretty readily at that point. Even going up to 40 degrees, not a big deal. So here we have our power going into the timer motor, and between 3 and 2 are our contacts. Most of the time there's going to be power going directly from 3 to 2 and powering the thermostat. And if the thermostat calls for the solenoid, it'll close and the evaporator fan will operate. Fan switch wiring. The fan motor switch. Some customers want the fan to shut off during defrost. It all depends on how critical what they have in that is, how critical that temperature is. If you have a heated defrost, you're definitely not going to run the fan. The switch may serve as a service disconnect. Yeah, I'm not so sure I like that plan. Guys, you want to put a disconnect in there, a regular disconnect. It sucks getting electrocuted when all you're trying to do is change the time. Fan switch must also turn off refrigeration. If not, the evaporator freezes and floods the compressor. If there's no airflow and it's not designed as a coil that way, then it's going to frost up really quickly. And we've got a wiring diagram with fan switch in it. So here's our fan switch right here. Doesn't really say where our coil for the fan switch is. Anyhow, with the fan switch, we can kill power to everything. You know, the solenoid can't get back to neutral if the fan switch is open. Neither can the fan run. So that kills refrigeration and the fan just by putting that little switch right there. Fin spacings. The wider the spacing, the slower frost builds up. You can tell what kind of coil you have by the fin spacing. If you look at an air conditioning coil, those fins are very, very close together. If you get it in just the right position, you can see light through it, but I won't be able to see any of your faces, just that there's light going through it. If we get a medium temperature coil, I'd be able to zero in on a face. You get a low temperature coil, it's going to have some pretty wide spacings in there, and that's all about knowing that you're going to have ice build up and still having a space for air to flow into that thing. The medium temperature evaporators, about 10 fins per inch. Low temperature evaporators, 7 fins per inch. And there we go, we're measuring the fin, and I'll normally start without this thing. 1, 2, 3, 4, 5, 6. Go ahead and say 7, 6.5, because we don't really start right on that. So we got about 7 fins per inch there. That's a little bit wider. Low temperature evaporators designs. Sometimes they're going to have heaters in it. A defrost heater. In that reach-in box, we've got an electric heater in there, don't we? So that might be a consideration. I'm pretty sure that time clock's going to have to work. If they put a heater in there, I bet you it needs it. Our freezers often require heated defrost. That can either come from electrical defrost, or it could be hot gas defrost like we talked about earlier with the ice machine. Defrost termination and fan delay. And return system to freeze. So you're going to have some little system that goes on, like a heater safety that prevents overheating. The defrost clock, programmed to start defrost. Here's our heater safety switches right here. And also you can see the wires coming from our electric defrost. And oftentimes, sometimes an electric defrost will be right on the face of the coil, and other times there'll be vacant tube holes, you know, where there could have been a piece of copper, but instead they ran an electric heater in that. And they've got some interesting electric heaters. They're more flexible than you would think they are now. It used to be they just had, you know, there were two styles, this kind of hard aluminum rod that had a heater in it, and also there was this glass tube with a coil in there, which was kind of, I don't know, the glass tubes were weird. You're sure that that was a bad idea, but every now and then you'd come across a refrigerator where the glass tube had been busted, God only knows how long, and it's still working. You know, most normally when the glass tube broke open, that would be that. You're good?
Good. Key to that lab door.
Yeah.
Slag, right?